guys, inshallah today we're gonna talk about force and density. First, we want to know about the density, and these are the objectives of the new Cambridge updated syllabus. As you see, we have the new definition for density. Density is the mass per unit volume. So take care about the new definitions and symbols. So first, the definition for density. Actually, يا شباب, density is the mass per unit volume of the material. Because we have rho equal m times v, so density equal mass over volume, and we can put this rule in the triangle as you see in front of you. So I'll put here m, and down we can put rho times v, so you can get any one of them according to the given. Yani if he asked you to get the density, so rho equal m divided by v. If he gave you rho and m, he asked you to get the volume, so v equal m divided by rho. If he asked you to get the mass, so m equal density multiplied by volume. Okay. The second thing about the units here, if the mass of the substance in gram and volume in cubic centimeter, so what will be the unit for density? It will be gram per cubic centimeter. But if the mass in kilogram and volume in cubic meter, so what will be the unit for the density? It will be kilogram per cubic meter. So according to the unit of mass and volume, I can get the unit for density. So here, if the mass in gram, volume in cubic centimeter, so the density will be gram per cubic centimeter. Mass in kilogram, volume in cubic meter, so the density will be kilogram per meter cube or cubic meter. Okay. Floating. Actually, you know the density of the water equal 1 gram per cubic centimeter. So this means that if you have an object and this object has density greater than 1 gram per cubic centimeter, so this object will sink underwater. But if the density of the object less than 1 gram per cubic centimeter, it will be float on the water. So this is what we said about the floating. If we have the density less than 1 gram per cubic centimeter, it will float in the water. But if the density is or greater than 1 gram per cubic centimeter, it will sink in water. Measuring density. We said density equal mass divided by volume. So if we want to measure the density, we can measure the mass and measure the volume. We can measure the mass. How can we measure the mass? Actually, we can measure the mass by using balance. And then we can measure the volume. As we said before, we have to mention if we have regular object or irregular objects. If we have regular objects, so we can use mathematical formula. If we have irregular objects, so we can use the displacement method to obtain or to get or to record or to measure the volume of this irregular object. Then divide the mass over volume to get the density. Okay, so this will be the balance as you see, but let me tell you something very important. You have to take care about the zero error. If I want to measure the mass of any object, without putting anything on the balance, it must give me reading zero reading. Okay, so we can put after that, we put the object on the balance to get the quantity of the mass or to get the value of the mass obtained. Okay, so this will be the top balance as I said, and take care about the zero error. Okay, if I want to get the mass of the liquid, how can I get the mass of the liquid? Actually, we'll get the container and we can measure the mass of this container, and then I'll pour the liquid inside the container and then record the second mass, then subtract M2 minus M1 to get the mass of this liquid. So we can get the mass of the liquid by subtraction method. Okay, just the difference between the two values, as I said, that will be the mass of the liquid. The volume can be determined in a couple of ways. Actually, to get the volume, as I said, if we have regular shapes and irregular shapes. طبعا regular shapes like cubes, spheres, cylinders. Actually, I can use ruler to, for example, if I want to get the mass for the cube, length times width times height. And I can measure each side by using ruler. Then multiply length times width times height to obtain the volume of cube. or by using digital calipers. Digital calipers to obtain the accurate reading for example, the diameter or the radius of anything I want to measure. So here, the width and length can be measured by using ruler, or as I said, a pair of digital calipers. I can get the measurement, several times should be taken between different faces to obtain accurate results. Okay. And we can use the rules, as I said, the laws for the sphere, volume of the sphere, 4/3 by r cube, r, which is the radius for the sphere, cube, length, width, height, multiply, and cylinder by r square, l, which is the height of the cylinder, as I said before. Here we have worked example. A paving slab. A paving slab has a mass of 73 kilogram and dimensions 0.04 meter times 0.5 meter times 0.85 meter. Calculate the density in kilogram per cubic meter. You have to take care about the unit, because for example, if the unit here in the question centimeter and he asked you to get the quantity in meter, so you have to convert the units. So take care about the units in the questions and in the thing he asked you to get. So here he said in kilogram per cubic meter, and here we have meter, and kilogram. So no need to convert anything. So just here. So if we want to calculate the density, we have to calculate the mass and then divide it by volume. So first we have volume, we have cube. So what about the volume for the cube? Length times width times height. So first we have V equal length times width times height. So equal, we have 0.85 times 0.5 times 0.04. Okay, just multiply all of them to obtain 0.017 cubic meter. So this will be the volume. And after that, he asked you to get the density. So rho equal mass divided by volume. So here we have rho equal mass, which is what? Which is 73 kilogram. We will not convert anything. So 73 divided by 0.017. And you can obtain the final answer, which is 4300 kilogram per cubic meter. So let's write it here. So equal 4300 kilogram per cubic meter. We will not convert anything. So this will be the density and the final answer for the density of this substance. Examiner tips and tricks. He said you have to take care of the converting between units like meters and centimeters. For example, if you want to convert from larger unit into smaller unit, you multiply. Like what? From meter to centimeter, multiply by 100 or 10 to the power of 2. But if you want to convert from smaller unit to larger unit, divide. Like gram, I want to convert it to kilogram. So it will be divided by 1000 or times 10 to the power of -3. So 5 divided by 1000 or 5 times 10 to the power of -3, you'll obtain the answer in kilogram. So take care about that. How can you convert between prefixes, as we said before. Irregular shapes. Actually, we said it before many times. I can use many methods to calculate and to measure the irregular shape. For example, if I have this irregular shape, as you see in front of you, which is in green color, first I'll get Eureka can and I'll put water here until the water reach its spout, as you see here. Then I have measuring cylinder. I'll put then the this regular or irregular shape. I'll put it in the water. So what will happen? The level of the water rises. So it will move through this smalling tube till the measuring cylinder. So I can measure the water here. That will be in the measuring cylinder, and this will be the volume of this irregular shape. This will be the volume of this irregular shape. Okay? Or we can use the method we said it before. Just we can get a measuring cylinder and I'll pour some water inside it and record its reading. And this will be the volume for this water. And after that, I'll put the irregular object inside the water, so the water rises up. Then V2 minus V1 to obtain the volume of the irregular object. So you can use any one of them as you like. Okay. If you have two immiscible liquids, يعني two liquids not mixed with each other, each liquid has its own density. We can compare between the densities of these liquids. We have higher density and lower density. The lower density will float, while the greater density will sink. For example, if we have density of the water or of the oil equal 800 kilogram meter power negative 3, and density of the water equal 1000 kilogram meter power negative 3. Okay, so which one will float and which one will sink? As you see, the density of the water greater than density of the oil. So this means that the oil will float while water will sink. So here oil has lower density than water. So the oil will float on the water.